So we've imported our animal shelter data. Say we wanted to look at the age the animals were when they entered the shelter, which is described by this age.intake variable. If I go back into my script and I want to look at that variable, I need to give it the data frame name first, animal shelter data, then use a $, and then type out the variable name. This is a good time to mention that R is case sensitive. So if I ask for the age@intake variable from the animal shelter data frame, it's going to output every single value of that variable. If I forget to capitalize one of the letters here in age.intake with a lowercase I, all it sees is a variable that doesn't exist in your data set, so it's going to give you a bogus answer. Now that we know how to call out a specific variable from a data set, I'm going to go through just a couple example functions that we're going to be using in this lab. If we want to know the mean age of intake for these animals, we can use the mean function. Notice that the function name is going to be used first, and then the arguments for that function are going to be put in parentheses. So if I want to know the mean of this variable, I can simply copy it, since I've already got it here, put it in between the parentheses, and now R is going to give me the mean of the age of intake variable in my animal shelter data. And if I run it, it's going to output it in the console window. So the mean age of animals that entered the shelter in 2012 was 2.35 years. Now if I just enter this command like it is, R will output the answer for me. I can also assign it to another object. So remember, we've got x and y in there that were assigned to some algebraic expressions. I can do the same thing. I might want to call this mean age. I could really call it whatever I wanted. If I use that assignment key and then have the mean expression, the mean function after it, I'm going to now have that mean age variable in my workspace that I can work with later if I need to. Another descriptive statistic function that we're going to be using is the median. Again, a fairly intuitive function name. Again, we only need to input one argument. We can ask for the median of any variable, and it will output the median value. So I could call this median age, run it, and now it's stored. So notice that the median age here is 1 year. Now a nice function that will give us a variety of descriptive statistics is this summary function. So summary is very similar to mean and median. It just takes one argument, which should be a variable of numeric values. So if I ask for the summary of age at intake, and I run that line, I'm going to get 6 pieces of information. The minimum age, which is 0, and the max, which is 17. Then I'm going to get the first quartile and the third quartile, which are 0 and 3 respectively. And then I'm also given the mean and the median. So from just the summary function, I can get my interquartile range, my mean, my median. The one other descriptive statistic we're going to be working with is the standard deviation, which I believe is SD parentheses, then the variable. If I run this, I'm going to get the standard deviation of that variable. Let's talk next about visualizing. For this lab and pre-lab, we're going to be looking at a single numeric variable for both assignments. And the way we would display that is, of course, a histogram. So the function for R for producing a histogram of a variable is just hist, open parentheses, variable name that we want to plot, and then remember to always include that closing parentheses there. If I run this, I'm going to get in my plot window a nice histogram of the age of these animals when they entered the shelter. So we might look at this histogram and describe this variable, this age variable, as extremely positively skewed. Most animals that enter the shelter are very young, say less than 2 years old, and just a very few of them are older animals. So let's say that we wanted to find the animal that was maybe the very oldest in our data set when it entered the shelter. We know that the maximum age is 17. But what if we want to know more about that animal, and we don't want to open up our data and scroll through all 473 animals and see where that age was 17? We can have R do this for us. So I haven't followed my own advice here, and I haven't been including a whole lot of comments. But let's include one now. Let's say we're going to find the animal, the oldest animal at the shelter. Now, if we want to know which record contains that maximum value, we can ask R to give that to us with a function called which. Which is a function that is a little more complicated. The argument is a little less intuitive, but it's basically going to return us a row number for some condition that we specify. So if we want to know which animal has the age at intake equal to 17, we can ask for which record that follows the following criteria. Animal shelter data, right, the variable name, age, intake, and we want to know where that variable equals 17. So R recognizes a double equal sign to mean the logical true statement, the logical equals. So it's going to say, okay, animal shelter data, age and intake equals 17. I will find in your data set where that expression is true, and I will return the row number. That's what the which statement is all about. So if we submit this line, it's going to give me a single row number since there's only one animal where that expression is true, and that row number is 415. So if I go into animal shelter data, and I go all the way down to row 415, which is right here, I can see the impound number, the date it arrived, it was an owner surrender, a neutered male dog. Here's our age at intake 17, R was right. So the which function can be very handy when you want to specifically call out a certain record without having to go through and find it yourself. Now we also didn't have to go into the data set and scroll to that row number. We could have asked R to do it for us. So when interacting with a data set, we can call out a specific row or column with just a simple syntax. Right, so if we go and we want to find within our animal shelter data the entire record where the row is 415, we can enter our data frame, we can use the square bracket, and we will give it the row, comma, column of whatever we want to see. So if we want row 415, we would enter 415 and then comma, and here we could enter any variable we wanted, any range of variables we wanted. We could give it the actual variable names. If I leave nothing there, it's going to give us every single column. So this is basically asking us for the 415th row of our animal shelter data. And we're going to see the variable name and then the value for that one specific animal. And so we could get a nice snapshot of what that dog was like by using this command. If we wanted to calculate the z-score of that dog's age, find out maybe how unlikely it would be to be that old and enter the shelter. Of course, we would only interpret this if we had a symmetric distribution, but just to get familiar with the code, we can, again, remember, input any sort of algebraic expression we want into R. The z-score formula is just a simple ratio. It's the value of your variable minus the mean, that quantity over the standard deviation. So if we wanted to assign a variable to that value, that z value, we could call, let's just say, z age, and let's define that as my 17-year-old dog minus the mean of my animal shelter data age at intake, right? We could also write out that mean if we had had it in our output before, or we can just ask R to calculate it again for us in this expression. And we want to divide that entire expression by the standard deviation of our variable. So if we submit this line, we should now have a new object called z-age, and this will be the z-score of that one animal. So 4.7 is a very large z-score. If we wanted to know the proportion of ages that are less than that, given this variable were normal, say, we could use another function called pnorm, which only takes the argument z-age, basically a z-score. if we run this, we're going to get the proportion of a normal distribution that is to the left of our z-score, which was 4.72. And we see that this is almost equal to 1, right? There's very, very few dogs or animals that would be older than 17 entering the shelter, given this distribution. So a final thing I want to show you how to do in R is subsetting data, which is a really important skill to master for any of these labs that we're going to be having in the course. So we've already seen logical indexing here, logical statement with our which command. We also see how we kind of grab either a row or a column from our data frame. So we're going to put those two skills together and create a new data frame that is just a subset of our original. So this might be useful if we're trying to pull out only animals with a certain attribute. Say we only want to look at the age of intakes for dogs. First, we have to come up with a name that we're going to call this new data frame. We can call it, let's say, dogs. And what we can assign it here is every animal in our current data frame, our current animal shelter data, where the type of animal is a dog. So first we need to know the variable name, which we can find by looking at our data here. Animal.type will tell us whether the animal is a dog or a cat. So if we want to pull out all the records that are dogs here, we're going to need to call that variable, animal.type. So we're going to start this expression with the name of the original data set. Right? We want to pull from animal shelter data. Now we're going to use those square brackets again. And now we're going to tell it, from animal shelter data, we want some number of rows and some number of columns. And we can specifically tell R which we want. Now for the rows, remember we only want to pull rows where the animal type is a dog. We can have R do that for us by just putting our logical expression into this first row element. So we can ask for animal shelter data, and I misspelled shelter, so that wasn't going to work. The $ animal.type, right, this is calling our animal type variable. And again, we'll use the double equal sign, and we're going to ask for dog. Now, any character variable in R, we can call it a specific value of that by putting it in quotes, right? If it was a numeric variable, we could just say equals 17, like we did up here. But for characters, we need to put those in quotes. So this is, again, is saying go into the animal shelter data frame, pull out the rows where this expression is true, right, where my type is a dog. And now I can ask for any number of columns. So I'm going to separate the row statement and the column statement with a comma. Here I could specify only pull out a certain number of columns. If I want all the attributes of all the dogs in here to just be kept, I can just put nothing past the comma. So let's just do this. Let's just make a data frame that contains all the information about our dogs. Call it dogs, submit it, and notice what happened. There's a new data set up here. It's got the same 24 variables, right? It's got every column from our original data frame, but only 291 observations. So there are 291 dogs in our original data set. And they are now all contained in this additional data frame called dogs. So the dogs data frame will act exactly like our original one did if we wanted to pull out the age at intake from just dogs. We could use dogs, $, whatever variable name we wanted, and this would give us 291 ages of those dogs. So subsetting is a little more complicated of a command, but just remember the logical indexing will tell you the cases you want to select and where to pull that original data from. Well, you need to pull it from the original data set, and you always define cases within a data set with those square brackets. So I think this R tutorial should get you up to speed enough to recognize the commands you're going to be seeing in the pre-lab. After practicing through the pre-lab with those commands, you all should be set for the lab assignment. Keep in mind that the students are not going to be moving this quickly. We're going to have a lot more resources to help guide them and get them comfortable with R. And again, we thank you for taking the time to work through this sample unit for us.